So in this video, we're going to be talking about coordinate systems. You've had a little bit of an introduction to them, and now we're going to specifically talk about the Cartesian coordinate system. A coordinate system in general is a set of unit vectors that describe the space, and using these unit vectors, we can then describe other vectors. Basically, they're like a set of directions that allow us to then describe other vectors. And so we're going to talk about the Cartesian coordinate system because that's the one we're going to use the most often, at least in Intro to Physics and probably in Physics 1 as well. There are other coordinate systems. You can see a few examples here. Again, it is a set of unit vectors that define the dimensions of the space. The Cartesian coordinate system is also called the rectangular coordinate system. And in the Cartesian coordinate system, you have unit vectors x hat, y hat, and z hat. And those three unit vectors are mutually perpendicular to each other, so they all are perpendicular to each other one. And those are the unit vectors that we're going to use to describe the Cartesian coordinate system. Other unit vectors or other coordinate systems you might come across, cylindrical coordinate system. It's also called polar coordinates, spherical coordinates, kind of depending on the shape or the space that you're describing. One of these might be more useful or easierly used to describe that space than the others. But we're going to focus on this Cartesian or rectangular coordinate system. Like I said, the unit vectors that describe the space in the Cartesian coordinate system, x hat, y hat, and z hat. And they are all perpendicular to each other. So the three dimensions of space, they're going to be described by these unit vectors. So if you remember our dimensions of space, we kind of talked about these when we described vector directions in general. You have like horizontal dimension, the vertical dimension, and then you have that third dimension that comes into or out of the board. And so these three unit vectors describe those three dimensions of space. In this picture that I'm showing right here, x hat is the unit vector that's pointing out of the board, y hat is pointing to the right, and z hat is pointing up. It's really important to remember that there's a 90-degree angle between each of these unit vectors. So they are all perpendicular to each other. So again, describing space in general, three dimensions. The plane of the board, like the computer screen that you're looking at, that describes a plane, which is a two-dimensional object. It can go left and right, up and down. Those are the dimensions. So the directional sense in like the horizontal dimension, left and right. The directional sense in the vertical dimension, up and down. And likewise, there will be a dimensional sense in that third dimension, out of the board or into the board. Okay, so remember all of those six directional senses that describe how you can point along any of the three dimensions of space. Okay, so out of the board and into the board. And you've seen this before, but let's show it again. The symbols to describe out of the board or into the board. We use these symbols so that we can kind of describe these dimensions of space, and I'll show you that in just a second. In order to describe the Cartesian coordinate system, we're going to use something called the right-hand rule. This right-hand rule is going to tell us which of the directional senses along each of the dimensions of space is in the positive sense. So get your right hand out and make this shape with your right hand, where you kind of make an L with your pointer finger and your thumb, and then you let your middle finger kind of point outwards from your palm. This is called the right hand rule. That's the shape you want to make with your right hand. The next thing you're going to do is you're going to assign the unit vectors according to this assignments that I have listed here. So x hat is going to be your pointer finger, y hat is going to be your middle finger, and z hat is your thumb. So notice that each of your fingers is 90 degrees to all of the other fingers. And we have that assignment. That's what's going to tell us the positive directions of each of these dimensions of space. So the way that your fingers point tell you the positive x direction, the positive y direction, and the positive Z direction. So notice that you can move your wrist, you can twist your wrist, you can change like the directions that each of your fingers is pointing at, but they're always going to maintain that 90-degree angle between any of them. And so the Cartesian coordinate system, it's not set in stone that you might think that like x hat needs to point to the right and y hat needs to point up, which makes z hat come out of the board. That is one possible combination of the unit vectors that could be used to describe the Cartesian coordinate system. But really any way that your hand, that your wrist and your arm can point, that is also a valid assignment for the Cartesian coordinate system. So I could have x hat pointing into the board, I could have y hat pointing to the right, and I could have z hat going down. So you can choose two of your unit vector directions, and then your hand tells you the direction of the third one. Okay, so remember those assignments. X hat is pointer finger, y hat is middle finger, z hat is your thumb. All right, so going back to those directional senses, you know that in the horizontal direction you can be pointing either left or right. In the vertical direction you can be pointing up or down. And in that third dimension you can be pointing into or out of the board. The symbols that we use to describe pointing into the board is an X with like a circle drawn around it. And coming out of the board is like a little dot with a circle drawn around it. The reason we use these symbols is just like an arrow that's like being shot into the board. You would see the crosshairs of the arrow as they go away from you and they're shooting into the board. And if that arrow is coming out of the board, then you would see the tip of the arrow coming like straight to your face as it's shooting out of the board. So those are the symbols we're going to use to describe the different directional senses. The way that however the unit vector is pointing, that is going to describe the positive directional sense in that dimension. So if x hat is pointing to the right, then that means that that is the positive x hat direction. It implies that left would be in the negative x hat direction. If y is pointing up, that's the positive y hat direction. Then pointing down would be in the negative y hat direction. If z is coming out of the board, then that means that's the positive z hat direction. And then going into the board would be the negative z hat direction. All right. Like I said, you can choose two of those directions. So you can choose that maybe x describes the horizontal direction and y will describe the vertical direction. That forces z to describe the third dimension, and it forces the directional sense of that. So if you have x going to the right and y going up, your thumb is coming out of the board. It has to be that way. It's defined by the right hand rule. So let's do some examples here. Let's say that you have this coordinate system where you've chosen x hat to point up. So that means point your finger going straight up. You've chosen y hat to go to the left. So make your middle finger point to the left. When you allow your thumb to kind of point perpendicularly away from your palm, you'll notice that you should see the tip of your thumb right now. So that means that the z direction will be pointing out of the board. So I'm going to use that symbol there to describe out of the board. All right, let's try another one. Let's say that, let's say we don't know x. So I don't know how to point my pointer finger, but I need y hat to be coming out of the board. So look at the tip of your middle finger. That's y hat coming out of the board. And now turn your palm, turn your whole arm, so that z hat is pointing up. That means that your thumb is pointing up. So I am seeing the tip of my middle finger. My thumb is pointing upwards. My pointer finger is going to the left. So that means that x hat is pointing to the left. Let's try another one. I have, now this time x hat is going into the board. So take your pointer finger and point it into your computer screen. It's going into the board. And I want z hat to go down. So that means your thumb is pointing downwards. When I do that, my middle finger is pointing to the right. So that means that y hat points to the right. And in our last one, y hat going down. So that means that my middle finger is going down. Z hat is coming out of the board. So kind of turn your wrist, turn your arm so that you see the tip of your middle finger. Or sorry, not your middle finger, your thumb. My middle finger is going down because that's why. My thumb is coming out of the board so I can see the tip of my thumb. my pointer finger is going to the left. So that tells me that X is going to the left. All right, and that's how to determine the directional senses of the Cartesian unit vectors. Remember, in the Cartesian coordinate system, x hat, y hat, and z hat describe the dimensions of space. They are mutually perpendicular to each other, and their directional senses, the way that each direction is positive, is given to you by the right-hand rule. So make that shape where you make that L with your pointer and your thumb. Let your middle finger point perpendicularly outwards. That's the shape you want to make with your right hand. And then you make that assignment that your X hat is your pointer, Y hat is your middle, and Z hat is your thumb. All right, and that's how you do the right-hand rule in order to figure out the senses for the Cartesian coordinate system.